Hey everyone, ready for another deep dive. Today we're tackling NGRX signals. And from the looks of your notes and articles, you're really getting into reactive state management for your Angular
Oh
projects.
yeah, it's really interesting stuff.
Yeah, signal store, signal state, custom features, even integrating with RxJS. I mean, there's a lot to unpack here.
Yeah, where do we even begin?
Well, I guess a good place to start would be like, what problem is NGRX signals trying to solve?
Well, it's really trying to solve a problem that's been around in Angular for quite some time, and that's like, how do we handle state in a really powerful but also intuitive way?
Right.
And I think a lot of the traditional approaches they often felt a little bit clunky. There's a lot of boilerplate. It could get complex.
Yeah, I've definitely been down that road before. You get lured in by these frameworks that promise simplicity,
Right.
and then next thing you know, you're like knee-deep in debugging nightmares.
Yeah. I think it's healthy to be skeptical, but what sets NGRX signals apart is that it's built on these principles of like the reactive programming, which, when you get the hang of them, can really simplify how you think about like state changes in your application.
Okay.
And it's also, super lightweight and really performant.
Okay. I'm intrigued, but before we get into the nuts and bolts, can we just take a step back?
Sure.
What exactly iOS NGRX signals?
Yes. Like, at its core, NGRX Signals is a standalone library.
Yeah.
And it's all about giving you this toolkit for working with Angular signals.
Okay.
Really, it's all about reactivity, like making sure your app responds to state changes in a really smooth and predictable way.
Right.
But the real beauty of it is in how flexible it is.
Yeah.
You can use it for like really simple state management, just in a single component, or, you can scale it up and use it for like this really complex global state for like your entire application.
So I'm looking at these docs and I see Signal Store mentioned a lot. Would you say that's like the heart of NGRX signals?
Yeah, I think you could definitely say that. I mean, Signal Store is your go-to for like that real comprehensive reactive state management. Okay. It's where you define your state, where you can figure out computed values and really how you handle all your updates. Think of it as the central hub for all things state.
All right, well, let's dive into Signal Store then. I'm seeing here you create a store using a function that's, cleverly named Signal Store.
Right.
What's going on under the hood there?
So the Signal Store function is like your entry point.
Okay.
You pass it an object, and that defines the initial state of your store.
Okay.
And, this could be like a really simple empty object, or it could be like a really complicated structure, representing some part of your application data.
So let's say I was building like an e-commerce app. I might have like a cart store with an initial state that's just an empty array.
Exactly.
Like to represent, an empty cart.
Yeah, and you would use the with state feature to actually, define the structure of your cart state. Like what items you have in there, maybe quantities or discounts, stuff like that.
Gotcha. Okay, so we have like our cart store blueprint. How do we actually make this store available to the components that need it?
So you've got options there. I mean, if the seat's just for, like a specific component or route, you can provide it just locally.
Locally, yeah.
Yeah. But for something like a shopping cart, which you're probably going to use, across your app, you're going to want to provide it globally.
Yeah.
At that root level.
Root level, that makes sense. Okay, so assuming my cart store is all set up and accessible, how do the components actually read from it and how do they interact with the state?
So this is where like the magic of Angular signals really comes into play. So when you define your state using, that with state feature, NGRX Signals is going to automatically create these signals for each property.
Oh, wow.
And these signals, they're like these reactive handles to your state.
So no need to create observables or any of that.
Nope. NGRX Signals, it takes care of all that.
Yeah.
All that heavy lifting for you. You just inject your cart store into the component, and then you just use the signals to read and display those values.
Okay.
So, you want to show how many items are in the cart, just use that cart items.length signal,
Yeah.
right? You want to display the total price. There's a signal for that too.
This is sounding pretty slick. But what about those times where you need to derive values from the state?
Okay.
Like, let's say I want to display the total price, but I have to factor in quantities and maybe some discounts.
Right.
I can't just display the price as is.
That's where the with computed feature really shines. So instead of manually calculating it every single time something changes, you're going to define a computed signal using that with computed. And this signal has access to all your other state values, and it'll just automatically update whenever those dependencies change.
So it's like a reactive formula.
It can-
It's just staying up to date for you.
Yeah, and it does it efficiently. It'll only recalculate when it absolutely needs to, which is great for performance, especially for, complex apps that have a lot of derived state.
Okay. Starting to see the appeal here. But we're still missing a key part, which is like, how do we actually update the state? Like, how do we add items to the cart, apply discounts, that sort of thing?
That's a good point. We need to be able to update the state. So we use with methods.
Okay.
And what this lets us do is define methods on your store specifically to update the state.
Okay, so for our, trusty cart store, we'd have like add item, remove item, apply discount.
Yeah, exactly. And inside those methods, you're going to use the patch state function. And what that does, it updates the state, but it does it immutably. And this is important because it makes sure that your changes are predictable and easy to work with.
Okay. Immutable state.
Oh.
I hear that all the time as like a best practice, but, I never really got why it's so important. Could you elaborate on that a bit?
Yeah. So basically, it means you never change the state object directly. You always create a new one. And I know it might seem like a lot of work, but it makes things so much easier.
How so?
Well, for one, it's easier to track those changes.
Yeah.
And you can debug your application more easily. Because if you're creating new objects all the time, you have like this history of how your state's been changing over time.
Okay. Yeah, that makes sense.
And it's super valuable for debugging. Plus, it has some really good implications for performance and change detection.
Really?
Yeah, because when you change the state directly, Angular's change detection has to, work so much harder to figure out what changed.
Okay.
But with immutable state, Angular can just be like, oh, this object reference is different. It's a breeze.
So that's leading to, a more efficient, smooth experience for the user.
Yeah, exactly.
Yeah.
And it makes things like Underado or syncing state across, multiple users so much simpler.
Wow. Okay. I'm starting to see the light here. But getting back to our cart store, what if adding an item involves an API call,
Okay.
to check inventory or calculate shipping or something like that? That sounds like, it's going to get asynchronous and complicated.
Yeah, you're going to need to bring in RxJS for that. You can integrate RxJS observables right into your store methods.
Okay.
Super easy.
So I could define an add item method, and it would use an observable to make that call.
Right.
And then when it gets a response, it could use patch state to update the state.
Exactly. And NGRX Signals has this really helpful utility. It's called Rx method, and it comes from the RxJS interop package.
Okay.
And it makes this whole process even easier. You can define these reactive store methods that really leverage the power of RxJS operators.
Okay. I'm definitely going to have to look more into that RX method thing. That sounds really cool.
Yeah, it's pretty neat. But there's one other really important concept I want to touch on, and that is protected state.
Protected state.
Yeah. So by default, NGRX Signals, it kind of enforces this principle that state can only be updated from inside the store.
Okay.
And what that means is it's preventing, accidental or unintended changes from outside, which could be a debugging nightmare.
So it's like having a security guard standing outside your state, making sure nobody's messing with it.
Exactly. And what this does is it keeps your state consistent and predictable. So
Right.
it's way easier to work with and debug.
All right. I can definitely see the value in that. But are there ever times where you might want to disable that protection?
Sometimes, yeah. But it's important to be really careful because you can end up with tighter coupling between your components and your store.
Yeah.
And that can make your code harder to maintain and refactor. So, it's best to really consider all your other options before you go down that road.
So it's it's there if you need it, but treat it like, a last resort kind of thing.
Yeah, exactly. It's like a safety net, to make sure your state's in good shape.
All right. Well, this is all super robust for managing complex state. But, what about those times where you just need something simple and lightweight? For managing the state of a single component.
You're thinking of signal state.
Bingo.
Yeah.
I'm looking through the docs, and that seems perfect for, those smaller state management needs. How is that different from Signal Store?
So signal state, it's like a little utility knife, for managing single base state right in your components or services.
Okay.
It doesn't have all the bells and whistles that Signal Store has, but it's perfect for those quick and easy situations.
So like if I'm building a, I don't know, a simple counter component,
Right.
I might use signal state to manage the counter value.
Exactly. You would start it off with signal state and, set the count to 0.
Okay.
And then, use patch state to update that value.
And could I also use signal state in a service to manage like the loading state of an API request?
Yeah, absolutely. You could have properties for loading or for your data or for errors
Okay.
and use patch state to update them as that request progresses.
So we've got signal store for like that complex, potentially global state, and we have signal state for those smaller, more localized needs. This is feeling like a pretty complete toolkit.
Mm.
Now, what about these custom features? I keep seeing that mentioned, but I'm not quite sure what they are.
So custom features, that's where you can really start to leverage the power and flexibility of NGRX signals.
Okay.
You can extend the core functionality of Signal Store in a way that's really tailored to your application.
So it's like building your own toolkit on top of the already powerful like NGRX Signals foundation.
Yeah, I like that analogy.
Yeah.
So let's say you're building an application that's got, a lot of asynchronous operations.
Okay.
And you're finding yourself writing the same logic over and over again for things like loading states or error handling.
Yeah, that's a lot of boilerplate.
Exactly. But with custom features, you can take all of that logic
Okay.
and encapsulate it into a reusable feature.
Yeah.
And then you can just apply that feature to any store.
So like I could have like with a pair request status feature, and that would like automatically add those loading, error, and data properties to my stores along with helper methods.
Exactly. And then you can just apply it to any store that makes API requests, and you don't have to write all that code again.
This is powerful stuff.
Yeah, it's really cool. And it's not hard to create these custom features either.
Really?
You just use the Signal Store feature function to define it.
Okay.
And then you can use those familiar tools like with state, with computed, and with methods to build it out.
So it's like building a mini signal store within a signal store.
Yeah, you could think of it that way.
Yeah.
And the best part is you can make them as simple or as complex as you need.
This is opening up all sorts of possibilities.
Yeah.
You could create features for logging, validation, even undo functionality. But, before I get too carried away, how do you test all of this? Testing state management can be tricky.
Testing NGRX signals is actually really straightforward, especially if you use Angular's testbed. You can mock out dependencies and, write assertions against the public API of your stores, and even test, how your computed signals and methods are behaving.
Okay, could we walk through a quick example?
Sure. So let's say you've got a movie store, right?
Okay.
And it has a method for fetching movies from an API. So you could use testbed to create a mock service that returns, a set list of movies.
Yeah.
And then you'd inject the movie store into your test and trigger that fetch method.
And then you would use assertions to check if the loading state is updating correctly. And once that mock service resolves, check that the, movies array has the expected data.
Exactly. It's all about testing that public interface and making sure everything works the way it should.
Okay, that's way less daunting than I was imagining. But speaking of concerns, I did see a section on frequently asked questions. Were there any that you thought were especially important?
Yeah, one that comes up a lot is about connecting Signal Store to Redux DevTools.
Redux DevTools, yeah.
Which is a popular debugging tool. And, while there's no, official integration just yet, there are some community-driven solutions and, some tools, with DevTools from at Angular Architects Makes EX Toolkit.
Okay, that's good to know.
Yeah.
What about the relationship between NGRX Signals and the traditional NGRX Store? Are those two competitors, or can they work together?
Oh, they can definitely work together. It really depends on the situation. Signals don't have a built-in idea of time, like actions and events happening over time.
Yeah.
That's what the global NGRX Store is for. So if you need to manage, a sequence of events, you'd stick with the global store.
Okay.
But in a lot of cases, NGRX Signals is just a simpler, more streamlined approach.
So we've covered a lot of ground. I feel like we've just scratched the surface here. We haven't even touched on entity management yet, which seems like a whole other fascinating aspect. Yeah.
Yeah, NT management's a big one for sure. And it can be messy if you don't do it right. That's where we should pick up next time.
Right.
Get ready to, streamline your handling of big collections of data.
This is getting me excited. We'll be back after a quick break to, dive into entity management with NGRX Signals.
Welcome back. Ready to tackle entity management.
I am, but I've got to admit, managing collections of data has always been, well, kind of a thorn in my side. Promises of clean code, you know.
I hear you.
And then it all turns into spaghetti as the app grows. What makes NGRX Signals any different?
Well, with NGRX Signals, it starts by, like, recognizing that entities have their own specific needs. It's not just arrays and objects.
Right.
So the Add NGRX Signals Entities plugin, it gives you a more structured way to handle these collections inside Signal Store.
Okay, I'm seeing this with entities feature mentioned a lot in the docs. That seems to be like the heart of this plugin, right?
Yeah, you could say that. Think of it like a blueprint for your entity collections. It sets up these essential signals that, like, simplify all the common stuff you got to do.
Okay.
And by default, it assumes each entity has a unique ID, like, ed property. But you can customize that if you need to.
So if I'm building, let's say, a task management app, and each task has an id, a description, and a status, how would I use with entities to, like, set up the structure for managing those tasks?
So you would add with entities to your task store definition, and you'd pass it, like, an object that defines the initial state.
Okay.
Which, could just be an empty array to start, or, you could pre-populate it with some tasks.
And then with entities just takes care of setting up all those signals for me. Like, what are those signals?
Yeah, so you get three main ones: IDs, entity map, and entities.
Okay.
IDs is just an array of all the unique IDs for your tasks. Then you've got entity map, which is like a dictionary. The keys are the task IDs, and the values are the actual task objects themselves.
So I could use entity map to, like, grab a specific task just by its ID? Like, I wouldn't have to, loop through a whole array to find it.
Exactly. It's super handy for that. And then there's entities, which is a computed signal. And that gives you just like a plain array of all the tasks.
Okay, that's pretty neat. So we have this nice structure set up.
Yeah.
But how do we actually, work with it? Like, how do we add new tasks, update them, mark them as done,
Right. That's where the entity updaters come in. They're these functions that work with patch state.
Okay.
And they just make it really clean to change your entity collections.
So it's like they're handling all the tricky stuff for me.
Yeah, exactly. So, like, let's say you want to add a new task, right?
Yeah.
You'd use the identity updater, and you'd pass it the new task object.
Okay.
And then patch state takes care of adding that to the collection, making sure you don't have duplicate IDs or anything like that.
So I don't have to, like, manually check for duplicates or worry about messing things up?
No, the updaters handle all that for you. And it's not just about adding, what if you need to change a task, like update the status or the description?
I'm guessing there's an updater for that too.
Yeah, update entity. It's super flexible. You can give it the whole updated task object or just the specific changes you want. And it even handles the case where, like, the task you're trying to update doesn't actually exist.
So it won't break my app.
Yeah, that prevents all those nasty errors. And, what about removing tasks? Like, if a task is done and you want to get rid of it,
right,
you'd use remove entity and pass in the ID. And again, it handles the case where the task might not be there, so everything stays nice and stable.
These updaters are they're like precision tools.
Exactly. And those are just a few, The entities plugin has updaters for, like, adding multiple entities, setting an entity, replacing the whole collection, all kinds of stuff.
Wow. It really does feel like they thought of everything. But what if my entities don't actually use an ed property? Like, what if they use a different property as their unique identifier?
That's a good question. Not everything uses aids. So NGRX Signals lets you define a custom ID selector.
Okay.
And you use the selected function for that. It basically tells the entities plugin, like, hey, this is the property we're going to use as the ID.
So if my tasks had a key property instead, I could just create a selected function that returns task.key.
Exactly. And then you'd pass that selected function to the updaters.
Okay, so the plugin knows exactly how to find and manage the entities, even if they're not using that standard aid pattern.
Right.
This is cool.
Yeah.
But what about those times when you have multiple collections of entities in a single store?
Okay.
Like, imagine our task app also has to manage projects,
Yeah, you're going to have multiple collections. And with entities lets you do that, create named collections.
Okay.
You just give each collection a unique prefix. It's like creating separate spaces for each one.
So I could have a tasks collection and a projects collection all in the same store, and they wouldn't clash.
Exactly. You'd have signals like, task SIDs, task entity map, project SIDs, projects entity map, all nicely organized.
That keeps things neat. But wouldn't it be better to like create separate stores for each entity type? Like, if the app gets really big and complex.
Yeah, I think that's a good idea generally, like a separate task store and a separate project store.
Okay,
It just keeps things more organized and prevents your stores from getting too big and messy.
makes sense. Now, there's one other detail I wanted to ask about, and that's private entity collections.
Okay.
What's the reason for making them private?
So private collections, they basically create a boundary between what's happening inside your store and what the outside world can see. It prevents components from like directly messing with the entity data.
So it's adding an extra layer of protection, making sure that all interactions go through the store's methods.
Right. It just helps to keep your data consistent and prevent those like accidental changes that can lead to problems.
This is impressive. NGRX Signals really seems to have thought through all the nitty-gritty details of data management.
Yeah, I think they did a great job of combining simplicity and power.
But I feel like we've just scratched the surface, Like earlier we talked about RX method with Signal Store. How does that play into entity management?
Now you're talking. This is where things get really interesting.
Uh,
So let's say you've got a method in your task store to load tasks, and maybe you want to filter them by project ID.
okay.
We can use RX method to make that method reactive, taking a projected signal as input.
So whenever that projected signal changes, the method would automatically fetch the right tasks.
Exactly. And would use RxJS operators like, switch map to handle the API calls and make sure we're only doing one request at a time.
That sounds like a real-time data pipeline.
Exactly. And you can even combine multiple signals to create like even more complex data flows.
Yeah.
Imagine fetching tasks based on project ID, but then also filtering them by status and then sorting them by priority, all driven by these reactive signals.
Oh, yeah, the possibilities are endless.
It's all about making your applications dynamic and responsive.
Mhm.
But before we get too carried away, there's this one common concern with complex state: nested data.
Nested data, yeah, that can get tricky.
Like, how do you handle those deeply nested objects and all the signals that go with them?
Right.
And, nested objects can sometimes cause performance problems.
Yeah, I've been there.
But NGRX Signals, it uses this thing called lazy signal generation. So those nested signals, they're not created until you actually need them.
So you don't have to pay the cost for all those signals up front.
Exactly. It helps keep your app running smooth even when your state gets really complex.
Wow, this has been a fantastic deep dive into entity management with NGRX Signals. We've covered so much ground.
Yeah, it's pretty amazing how it simplifies things.
But before we wrap up, I'm curious about state tracking. I saw in the docs that NGRX Signals has ways to track how your state changes over time. Why is that important?
Well, think about things like logging or Undorito features or even syncing your state with like a database.
Right.
To do that effectively, you need to keep track of those changes.
All right. What tools does NGRX Signals give us for state tracking? So what tools does NGRX Signals give us for the state tracking?
Well, we have a couple of really helpful functions: get state and watch state.
Okay, two functions. What are the main differences between them? Like when would I use one versus the other?
So get state, like the name implies, it gives you the current state value. But here's the thing: when you use get state inside a reactive context, like, in effect, it's automatically tracking the changes.
So if I have like an effect that's logging the state of my my counter store using get state, every time that counter changes, the effect would run again and log that new state.
Exactly. But there's something about effects that we need to be mindful of, and that's that they operate in a glitch-free way.
Glitch-free effects. That sounds pretty technical. What does that mean in practice?
Basically, if your state changes multiple times, within the same angular change detection cycle, the effect will only run once.
Okay.
It uses that final state value.
Ah, so it's like those rapid-fire changes get batched into a single update as far as the effect is concerned. That's good for performance, but are there times when I would actually want to, capture every single change, even if they happen super fast?
Yeah, absolutely. Like, let's say you're building an Undorito feature.
Okay, yeah.
You need to track every single state change, no matter how close together they happen, right?
Yeah.
So you can, rewind and replay.
That's a perfect example. You wouldn't want to miss those in-between states, so that's where watch state comes in.
Exactly. Watch state is perfect for, synchronous state tracking.
Okay.
It captures every single update, even those super fast ones,
Yeah.
within the same change detection cycle.
All right. Now, the docs mentioned that watch state is, tied to the life cycle of an injector. What does that mean exactly?
That just means that if you're using watch state inside of like a component, it's going to automatically start tracking when the component initializes, and it stops tracking when that component is destroyed.
Oh, so you don't have to manually clean it up or anything?
Nope. It's all taken care of for you.
That's handy. But what if I want to start tracking before the component's destroyed? Like after a certain time or based on some user interaction?
Yeah. So watch state has this destroy method you can use for that.
Okay.
So, you could set up a timer to stop tracking after, like 5 seconds, or call destroy when the user clicks a button.
So full control, I like it. One last question on this. What about those times where I need to use watch state, but I'm not inside of a component or a service, where I don't have a readily available injector?
Good question. In those cases, you can just explicitly provide an injector to watch state.
Okay.
It's really flexible.
Well, this deep dive has been incredible. NGRX Signals brings together so many important ideas like, reactivity and modularity, and it really focuses on developer experience, which I appreciate.
Yeah, I think so too.
I'm leaving with a whole new understanding of state management.
I'm glad to hear that.
But before we wrap up, I want to leave our listeners with something to think about.
Yep.
We talked about custom features, how you can extend NGRX signals, and we talked about how integrating with RxJS adds this whole other dimension of reactive power.
Yeah.
What are some ways that you can combine those two things to create even more advanced state management solutions?
That's a great question. And I think, it's a challenge to everyone out there.
Yeah.
To explore all the possibilities that NGRX Signals offers.
That's all the time we have for today.
Yeah, thanks for listening.
Thanks for joining us on this deep dive into NGRX Signals. Until next time, keep coding and keep exploring.